you guys. So this is problem number 10 from chapter 6 on inductors, and we have some initial conditions. Actually, I'll just read the problem from the start. It says the current in a 4 Henry inductor is 10 amps, and the general equation is that I of t is equal to beta 1 cosine 4t and beta 2 sine 4t, all of that times e to the minus t over 2. The voltage across the inductor at time 0 is 60 volts, and we want to calculate the power at the terminals of the inductor at time equals 1 second, and we want to also state whether the inductor is absorbing or delivering power. So I forgot to write one more given. We're also given that L is equal to 4 Henrys. So, 1 second, this pen is out of juice. Alright, so let's get started. So we know we're looking for power, right? And we know that power is equal to VI. And so we have I. What we want to find then is a general equation for power, so that means we need V. So in order to get V, we need to know that the relationship between voltage and the voltage across an inductor, and that is V L of t is L d I dt. So we know what L is, so we need to find di dt in order to do this problem. So that means I'm gonna park this L for just a second because that's 4 Henrys, and I don't want to have to manage that 4 Henrys on top of this complex differential. So what I'm going to do is first find di dt, because it's not hard, but it's a pain in the neck. So remember the product rule is, we're going to use the product rule to do that, says that the di dt is going to be this times the derivative of that plus this times the derivative of that. So let's go ahead and start with that. That's beta 1 cosine 4t plus beta 2 sine 4t times the derivative of that, which is just negative 1/2 e to the negative t over 2. That's the first part. The second part is this, freeze that, plus e to the negative t over 2 times the derivative of that. Derivative of cosine is negative sine, so that gives me negative 4 beta cosine of 4t and then plus derivative of sine is cosine, so this gives me 4 beta 2 cosine 4t. And this should have been a sine. Oh my goodness, I have lousy, crappy pens today. Beta sine. Okay, so now what I would like to do before I bring in the 4 into this, multiply everything by 4, start grouping things together. So an e to the minus t, will factor out, so we will factor that out and combine the sines and the cosines together. So let's put this relationship over here. V is equal to L d I dt. We need that. Oh, holy moly. None of the pens work. Okay, so when I factor out this e to the minus t over 2, I'm left with this times 1/2, so it's going to be 1/2, negative 1/2 beta 1 cosine 4t plus negative 1/2. So let's just write it all out actually. So this is going to be negative 1/2 beta 1 cosine 4t minus 1/2 beta 2 sine of 4t. And then here I have, I'm going to erase this to make room. Here I have minus 4b sine of 4t plus, here I have 4b, 4 beta 2 of cosine 4t. And it's easy to make mistakes, so I'm going to take a second, and I do make a lot of mistakes when I rush. So let me just make sure it jives with what I had before. Negative 4b sine 4t, 4b cosine. Okay. Yep. Okay, I don't appear to see any silly mistakes. So now we have cosine 4t and cosine 4t, and so we can combine them together by adding the coefficients. This will give me e to the negative t over 2 times, and this is going to be all that times negative 1/2 beta 1 plus 4 beta 2, that times cosine 4t. And then for the sines, I have negative 1/2 for the coefficients of the sine term. We have negative 1/2 beta 2 minus 4 beta 1. And that is times sine 4t. Okay, now I'm ready to distribute the 4 Henrys through. So we just found this piece. We just found dIdt. Now we're going to multiply by 4. So now when I multiply everything by 4, the coefficients will be 4 times. So then this becomes e to the minus t over 2 times 4 times negative 1/2 is negative 2. So this new coefficient is negative 2 beta 1 plus 4 times 4, 16, 16 beta 2 cosine 4t. And then over here we have plus, so the coefficients of the sine term will be negative 2 beta 2 minus 16 beta 1 sine 4t. Alright, so let me just take a second to check to make sure that there haven't been, oops, and I forgot to just, oh no I didn't. Okay, so negative 2 beta 1, 16 beta 2 cosine, and then plus negative, so plus negative 2 and 16. Okay, so far so good. So now what? So that is, so what is it that we just found? We just found voltage. And that's a really good thing because we have this initial condition that says voltage at time 0 is 60 volts. So we're going to go through and substitute t with 0. Well, when t is 0 here, the e term is e to the 0 power. Because it's negative 0 over 2, which is e to the 0. E to the 0 is just 1, so then this just becomes 1. Oh, God, horrible. So this just becomes 1. Over here, cosine of 4t, cosine of 0 is 1. So we have negative 2 beta 1 plus 16 beta 2 times 1. So basically we have this term, minus 2 beta 1 plus 16 beta 2. And then here, sine of 0 is 0, so all of that term goes away. So we have, one of our equations is 2 beta 1 plus 16 beta 2 is equal to 0. Okay, that is good. So, but that's one equation, and we have 2 unknowns. So we need to somehow find a second equation, and we're going to get that from the I term. Because we know the I of 0 is 10. So we're going to substitute 0 in here. So we have I of t is equal to beta 1 cosine 4t plus beta 2 sine 4t times e to the negative 1/2 power. So let's start putting in zeros. when you put in e to the negative t over 2 with e to the negative 0 over 2, that's just e to the 0, and that's just 1. Over here, when you put beta 2 sine of 0, 4 times 0 is sine of 0, and sine of 0 is 0, so that term goes away. And here, when we have beta 1 times 4 cosine of 4 times 0, 4 times 0 is 0, cosine of 0 is 1, so all we're left with is beta 1. And since I of 0 is beta 1, then beta 1 must be 10. So all I did was went through and put wherever there was a t, I put in a 0, and everything just went away, and I'm left with beta 1 is equal to 10. So now I know what beta 1 is, right? So negative 2 times 10 plus 16 beta 2 is equal to 0, therefore beta 2, which is going to be, I'm not going to do that in my head, beta 2 is equal to 5 is what I got. Beta 1, 16 beta 2. Hang on. So, oops, it's not equal to 0, you guys. 16, voltage at 0 is 60. Voltage at 0 is 60. So we have negative 2 times 10 plus 16 beta 2 is equal to 60, because this was V of 0. So then when you solve for that, beta 2 should equal to 5, because 60 minus 20 is 40, 80. So yeah, so 80 into 16, I should double check it, because, so 80 minus 16 should be 5, but I don't really like to do these things in my head, because, okay, so the beta 2 is equal to 5. So now we know beta 1 is equal to 10, and beta 2 is equal to 5. Now we know what the whole equation is. So we know that, oops, so this is voltage V of t, right? That's equal to e to the minus t over 2 times that. So now we can start putting in beta 1 and beta 2, and I did that. And so I'm going to let you do the math, but if you put in for 10 for beta 1 and 16 for beta 2, you should come up with a general equation for voltage of voltage is equal to e to the negative t over 2 times 60 cosine 4t minus 170 sine 4t. I'm so irritated with these pens. And then, so we know what beta 1 is, so now we know our general current equation is beta 1 is, so it's going to be 10 cosine 4t, and beta 2 is 5. So our general equation for current is I of t is equal to e to the minus t over 2 times 10 cosine 4t and 5 sine t. So we have both pieces. Now we can go ahead and find p. So we're not going to like do the whole foiling thing and multiply it out and find a general equation for power, because they didn't ask for a general equation. They asked for power at time equals 1 second. So we're just going to take P is equal to VI and evaluate I at 1 second and V at 1 second. So you're going to put 1 into where T is and come up with a number. And the trick here is to make sure that your calculator is in radian mode. If it's in degree mode, you'll get the wrong answer, because these equations are in radians. So that is the trick. And once you do that, so once you put V of time equals 1 second in here and in radians mode, your calculator should come up with, so you should come up with I of 1 is equal to negative 6.26, and V of 1 is equal to 54.25. So P is equal to VI, which means the negative 626 times 54.25 you should get negative 339.61 watts. And so, negative power means the inductor is delivering power to the system. So positive power means it's absorbing power from the system. And that is that problem. Remember to share the video if it helped you, and to also like the Facebook page. Thanks.